Hey everyone, got a few questions for you. Have you ever tried applying sunblock on a bright sunny day? And if so, have you ever wondered how or why it works? Maybe have you tried different sunblocks and noticed that some seem to rub on a little better than others? Have you ever wondered why that is? Well, I hope to answer some of those questions for you. But before we get into that, I need to talk about the sun. You see, the sun emits a variety of different lights every day. Some of it we can see, known as visible light. It allows us to see the green grass, red apples, blue sky. And this works because the sun shines its visible light onto these objects, and these objects then reflect light back at us. See, if a red apple reflects red light, we see red, and a green grass reflects green light, we see green. And if an object reflects all the colors of the rainbow, we see white. The sun, however, also emits invisible light. This is sometimes known as ultraviolet light. And this is the kind that you can't see, but you can definitely feel on your skin. If you've ever been outside in the sun too long, you might have noticed you get maybe a tan first, but maybe you get an painful sunburn, or worse, if you're out for too long, too many years, you might develop skin cancer. And this is really harmful. So what do we do to prevent the ultraviolet light from penetrating our skin? Well, we've tried a number of different things. Sometimes we'll wear clothes to protect our skin, we'll walk through shade, stay indoors. Other times though, we apply what's known as sunscreen to our skin. And sunscreen is a new technology we've developed over the past centuries that protects our skin from the ultraviolet light. There are particles that either absorb the ultraviolet light or reflect it off, therefore it never reaches our skin. However, not all sunscreens work the same or even look the same. And what we're going to do today is walk through a demonstration to show you how differences in the technology of developing these sunscreens can allow different effects to occur. So first, before we get into it, let's talk about the experiment itself. All you'll need to do this experiment is some dark construction paper, some Q-tips, and then finally you want some regular sunblock. It might say zinc oxide, or it might just say white film sunblock. And also nanoparticle sunblock, which might also be known as clear sunblock, or clear coating sunblock. And so what we're going to do, which is a very simple experiment, is we're going to just put a little bit on this Q-tip, a little bit of each ointment on this Q-tip, and try applying it to the dark construction paper. So you'll see here, got a little dab on the Q-tip, not too much. You see, it's really white. And you'll notice here, as I wipe it onto the construction paper, that I'm rubbing it in, I'm rubbing it in, I'm rubbing it in. And some of it's kind of absorbing, but you can still really see the white layer on top. I imagine that if you were to apply this sunblock to your skin, you might look like a ghost. Well, let's try the other sunblock and see what happens. So I'm just going to take a little dab of it over here. See, it looks about the same, it's still white, so I'll also tell you it's made of about the same stuff. But there's a little difference you'll notice. See, as I apply it and really start rubbing it in, wow, it's incredible. It's like it fades almost immediately into the construction paper. Wow. So it looks the same, but when I apply rubbing it on, it appears clear as opposed to white. Well, why is that? I bet if you apply this to your skin, you look really nice. You wouldn't have any white stuff on your skin at all. So why does that occur? What's happening here? Well, the secret to all of this is nanoparticles. You see, these particles here are really large from this sunscreen. They kind of look like this. They're so large, they reflect visible light as white light. That's why it appears white to you. However, these other particles from the other nanoparticle sunscreen, they have really tiny particles, known as nanoparticles. And they're so small that if you tried to line them up end to end on a meter stick, how many do you think it would take to fit on? 1,000? 10,000? A million? Try 1,000 millions, or 1 billion particles. 1 billion nanoparticles lining up end to end on a meter stick. That's how tiny these are. They're so small, in fact, that visible light passes right on through. It doesn't even notice it. Isn't absorbed, isn't reflected, just passes, transmits right on through. That's why it appears transparent on your skin, as the visible light is passing right on through. So anyway, this is just a brief demonstration of how bringing things down to the nanoscale really affects things on the macro scale. I hope you've learned something today, and remember, always wear sunscreen. This presentation was brought to you by the Center for Materials Research at Norfolk State University and by the Children's Museum of Virginia.